Welcome everyone. Good afternoon, good morning, good evening from wherever you are. Thanks for tuning in to the latest episode of Meet the Synchrononians, a space where Synchro users from all around the world get to come and showcase the wonderful projects they're working on and all the good 4D work they're doing. I'm Nick Sanders. I'm part of the sales team here at Synchro. We have Monika, the CEO of Frescon, which you'll hear more from very soon. And just a few house rules before we get going. Well, there's only one house rule, really. There's a chat box on the side, and please ask questions. It makes it a lot less awkward for me and Monika the more questions you ask. So please type away. Yeah, over to you, Monika.
All right. Hi, everyone. As Nick introduced me already, I'm Monika Filusch. I'm really excited to be here today and to present it to you today. I will be talking about the implementation and management of a BIM 4D model, and specifically the benefits and values it provides to our construction. And one of the projects we were involved in and used Synchro to develop a 4D model is the National Children's Hospital in Dublin. And this webinar is going to be solely based on this project and how Synchro helped in many aspects of coordination on this project. So to start with, I just wanted to give you a short definition of what 4D means to me. And this is like one of the best explanations of the value of 4D for construction, especially for the pre-construction and construction phase. I was participating in a 4D event in London in 2019 and it was organized by Bentley, and whilst discussing the importance of 4D in the construction industry, someone said that 4D is like the rehearsal of the construction process. And further made an example that if important events in our lives are rehearsed, like weddings, for example, among many others, why this is not standard practice for such important events like the construction project. It did make absolute sense to me, and since then I'm just surprised why this is still not done more regularly in construction, and that's why I'm really very excited to talk about it today. So I have worked in BIM 4D, in the BIM 4D environment for the past 10 years, and with Synchro for the past 5 years. In fact, the National Children's Hospital was the first project that gave me the chance to use this program for the first time. In my presentation, I'm going to showcase some of the reasons why the use of 4D is so important. I'm hoping that my presentation will give you more insight into the practicality of its use. So before we dive into the presentation and the project itself, just let me give you a short introduction about myself. I have been in construction industry for over 20 years, and if we count that both my parents also worked in construction, you can say I have been in my construction for all my life. The first time I got my hands really dirty on construction was with 18 when I started my plaster apprenticeship, and carrying all the plaster rubble from an old apartment block to the truck. It was not what I expected. It was an exhausting task, but something kept me going, and I continued my career in construction to this day. A few years later, I graduated my engineering degree in European Civil Engineering Management in Germany. And during my studies, one of my modules stood out for me, which was planning and scheduling. This was the first time I saw a Gantt chart, and I think this was also the moment when I fell in love with this topic and stayed with me until now. So since graduation, I have worked in project management roles on residential, hospital, industrial, pharmaceutical projects, and for the past 13 years, I'm one of the co-owners of Frescon, and I manage the BIM department in Frescon. At the start, I'm going to give you a better understanding of the scale of this project. And we will go through the project requirements for using 4D and the actual aspects of how we use 4D through Synchro. And I will summarize with the benefits and values and also some advice what needs to be in place in order to get the most out of 4D and Synchro specifically. The construction of the National Children's Hospital is currently still ongoing. Its structure is complete and the facade works are almost complete at this stage, and it is in the middle of the internal fit-out. The construction started in 2017 when BAM Building was appointed as the main contractor for this project. After completing the 4D sequence animation for the project tender for BAM, our company was engaged to carry this work into the construction phase with the use of Synchro. Once complete, the hospital is going to provide about 160,000 square meters of accommodation with a total of 6,150 rooms. The building consists of 2 basement levels, providing about 1,000 car park spaces, and it is 7-story high above ground level. The project from its very start is designed and coordinated with level 2. Over 100 companies are involved in this project, which means that there are over 450 BIM models provided by designers, the main contractor, and subcontractors that are being coordinated by the contractor's BIM team. So it is quite a large task too. So the initial requirements for this project in regards to 4D were mainly specified by the investor. These were to link the 3D model to the construction schedule and to report the progress of construction with monthly reports comparing the planned versus actual program. However, very early on, BAM recognized further advantages of using the 4D model, and very early on we started to use it as a tool to analyze the excavation sequence, the concrete work sequence, the main logistics setup in relation to cranes, to analyze specific areas where particularly that will become particularly complex, the interface between the frame, facade, and the fit-out program, but also as a tool to discuss any issues that were spotted throughout the 4D sequence and on site. And of course, we used it for the fit-out sequence analysis, the planned versus as-built reporting, and as a tool to really voice maybe a solution tool for differences of opinion. And through the ongoing work with 4D, we realized that the 4D model became a central point to many project members. It not only served as a tool to illustrate the construction sequence and the progress on site to the client, but also supported a clear communication to many others on site. As you can see on the slide, the planning team was divided into four main scopes with different teams: civil, structure, facade, and actually mechanical, electrical. Even though the program was linked regularly and updated across the teams, spotting any discrepancies between the scope milestones was very difficult because the program was just so large and complex. But also the construction team on site and in the office together with the remaining BIM team and of course the client were able to better understand the construction schedule. The 4D model really brought many people together and served as a central communication tool, which we will see in the following slides. So I'm gonna go now into the samples, so real examples what we did on the project. And the first one is the excavation sequence analysis. Our first usage is exactly that. So the site was very complicated. As I mentioned before, the building had two main basement levels, with the third basement level being an attenuation tank. To get to a level of minus 4.8 meters, that's what it was called, we needed to actually excavate about 16 meters. This had to happen in many levels and stages. And to illustrate that and to explain it to all the project members was very difficult. So Synchro here was an exceptionally good tool to have. So the excavation sequence had to take account of many constraints and challenges on site. These were the perimeter piling around the entire site, the depth of the excavation, and the required embankments that we needed to ensure for health and safety. There was an existing road running through the middle of the site that needed to be kept alive, as it served as the main access road to the existing hospital. And a new central road had to be built in order to remove the existing road and to enable further excavation. The earthwork had to be started on two fronts, the north and the south. And very detailed and complex drainage design installation throughout the site was a challenge, as well as the concrete works milestone that needed to be achieved. Many sources and tools were used to develop the correct excavation sequence, from the conceptual drawings, as you can see here on the slide, showing the extent, depth, and of the extent what we wanted to excavate. We used as well aerial photographs of the progress on site through drones. The site team provided as well a lot of valuable information about the quality of the ground, which helped us estimate the impacted slopes for each excavation. And the 3D representation of the excavation slopes was produced using Revit and imported into Synchro, and where it could then be linked to the schedule itself. We had many interpretations and versions of the sequence. I'm gonna play the video maybe one more time of the sequence, and every time it was linked back to the model, we were able to see overlaps between the end date of the excavation and the start date of the concrete works in particular areas. This could not have been spotted, but easily through the Gantt chart. We would have to imagine all the different extents of excavation and the different extents of the concrete works, and then be able to identify whether excavation in a particular area would be complete for the concrete works to start. So the most valuable benefits from this works was definitely the ease of communication to everyone, what the most efficient sequence is. There was no room for arguments throughout the team, really. So through ongoing meetings with the planning and site, we produce eventually a more efficient and streamlined sequence. And here's an example, as I mentioned before, here's an example of a discrepancy that we spotted throughout this scenario analysis. You can see that the orange areas, they are the excavation areas, and the green are the concrete works. So in some of the scenarios, actually, the concrete work started too early, and the excavation wasn't finished. So we had to redo the program again. But finally, the last version of the excavation works was resolved and issued to everyone. And eventually, the BIM planning team and our company were able to find what exactly the efficient sequence of the civil works. So you can see it here. You can see in the middle here is the existing road that needed to be maintained. And here the green now is the new proposed central road. Without the installation of this one, the existing road couldn't be demolished. Get forward and see it's more progress.
What tool was used to model that, Monika?
Say again?
What tool was used to model the geometry?
We tried many versions, but at the end we decided for Revit. So we used actually Revit, and it was easy enough then to chop and change the different extents in Revit. We first tried as well 3D Max, but it was too complicated. It turned out.
Fair enough.
Yeah. Okay. So the next example is the concrete work sequence. As the frame team had specific milestones to hit, it was very important to analyze the correct approach to the concrete core sequence. It might seem obvious of how and where to start with the first concrete pour. However, on this project, really nothing was very simple. Because of the deep excavation, we really needed to find the right spots for where the concrete works needed to be started, because there was just limited space as well for trucks going in and out. So the challenges here were a very complex structural design, specifically the slab structure. It had many recesses, different levels and depths across all levels. adding to that, the structure had a complicated concrete beam system and columns spanning across several floor levels. Because of that, the concrete core regions were very non-standard, and that made it very difficult to establish the most efficient construction sequence. There were also constraints arising from the excavation and the consequent space limitations, logistics, and the possibility of how to access the concrete zones at basement level without the possibility of using cranes at the very start. Here you can see some examples of the concrete structure, and you can see here at the bottom left really the layout of the core zone. So you can see how complicated they are. They are not straightforward because of the different levels of depth and recesses. You can see it here as well in the section. And those images really helped us a lot to understand the complexity and to actually explain as well to everyone why it is so complex. And so we made a lot of scenarios for the south side of the concrete frame first, because this was the first available area for us to start concrete works. And after many analysis and going back and forth with the program, we developed a sequence that highlighted the kind of, well, the best sequence as it is. But we applied appearance profiles highlighting the different crews. So we knew that we're going to have several crews working at any given time on the same in the same area. But obviously we had to maintain that no crew would be working on two fronts at the same time. So this was very difficult to show. Well, very difficult to show for the Gantt charts, but very easy to show for Synchro, so that everybody understood where someone is working. And it was also helping the planners really to know exactly that they are not using the same resources into areas. So the next topic I wanted to discuss is the logistics setup, and it had its own challenges. That all cranes had to be incorporated into the building structure. So for the most cranes anyway, openings had to be created for the crane shafts, because there were not many lift shafts and so on that could be used actually for the crane. And the timing was very significant because there was very little space on the site and surroundings, and all concrete works had to be carried out through static cranes. And there was no space really for mobile cranes for a longer period of time. And because of the cost of running the cranes as well, it was really significant to see when a crane could be erected and when it could be taken down. And we illustrated this as well through Synchro and the interfaces between the different scopes, like the facade and the fit out. You can see here an example of the program and an example of the Synchro illustration, where we identified areas of fit out in orange, and in green here the facade fit out, the facade installation. So the next topic is really about how constraints can be visualized. I was mentioning before already the central road that was running in the middle of the construction site, and really because it was a live road and served the existing hospital, the permanent future road which was running here needed to be constructed first before this central road could be taken down and demolished, and basically the building needed to be stitched together. So in order to explain that to all project members, we made the visualizations for this. So yeah, as I just said, the challenges were the permanent roads surrounding the building to the north and needed to be completed and open to the public traffic before the temporary central road could be closed, excavated, and the area open for further construction. the logistics methodology due to tight space and the excavation works, and the connections to already built building structure made the sequence intricate. Right. So here you can see some of the imagery really highlighting how we explain the sequence of the central road excavation and the construction with the drainage works and taking down the central road and then essentially the structure itself. You can see here just the video of how the building was basically stitched together in the middle.
Complicated build.
Very much so, yes, absolutely. And so the frame completed. So the next topic is the facade sequence analysis and how we did that. As the planning team for the facade works was separate to the concrete frame planning team, we were able to analyze the interface between the concrete frame and the readiness for the facade works that could be started after the concrete frame was finished. So the challenges here were that the construction frame needed to be ready, and the cropping between the floors needed to be removed between the floors before the facade works could start. The building areas needed to be weather tight to enable start of fit-out works, and several stages of facade works from installation of metal walls to curtain walling. So a lot of things had to be accounted for. It all needed to be coordinated and the sequencing established. The start dates needed to be given to subcontractors installing each facade element scope as well. So that was very important to do too. And here we can see the sequence of how the structural frame really interfaces with the facades and where it starts and so on. And because really the zones between the concrete frame, you know, where the regions are poured and the zones for the facades were very different from each other. And like in the Gantt chart, it was really difficult to check whether the concrete frame was actually going to be finished by the time the facade needed to start. Then we also added the analysis of the fit-out works, and this was as well really important because, as I just mentioned, the concrete frame had different zones, different work zones, just as the facade had different work zones, and so did the fit-out had also different work zones because of commissioning. So this was a big challenge, and illustrating that through Synchro made it quite easy to see and to understand where there might be problems, where facade might not be ready for fit out to start or vice versa. So the interface between the concrete facade and fit out works was a challenge to different work zones, the temporary structures, in regards to the propping between the floor levels and the availability of areas for fit out. And here's an example. Here's an example of the illustrations that we did for the fit-out works. Sometimes we use a Synchro video to show everyone how everything is going to be working out. But many times we use as well PowerPoint presentations like these, where we really synchronize the fit out sequence and apply it basically applied over a PowerPoint presentation. So month by month, you would see basically the differences of when fit out starts and when there is idle time and when it's being complete. And this is another version as a sequence, an animation. And in the blue, you can see where basically the fit outs can start because of the facade being weather tight at this point. So here you can see concept that it was very easy for everyone in the on site to understand what is happening at any given time and where the direction of the construction is going to go. Not only the planners, who understand the Gantt chart in itself, knew exactly what to do, but also everyone else on site. Then in regards to the planned versus as-built reporting, we always prepared a kind of like a 3 month look ahead for the client, where the proposed sequence was shown for the next 3 months where it's going to have, and then in regards to basically every other time, we would also issue kind of a comparison between what has been planned and what has been actually achieved in a particular time frame. And we used the collected data from the planning team and from the site team, how the frame was in progress and completed to create those reports. And actually many times, this is an example on the left-hand side, many times the concrete pour regions were quite different to what was anticipated. But it was, because of Synchro, it was quite easy to manage the differences, by slicing and dicing the different slab extents. So it was very easy to update that. And another topic, really the last topic that I want to go into today was because so many valuable detail was included in the program on an ongoing basis. And Synchro turned out to be a powerful tool to manage differences of opinions throughout the project. So just as the phrase goes, a picture paints 1,000 words, the same can be said about 4D Synchro. Without the graphical representation of what the situation looks like, whether in the past or in the future, discussions on a particular problem tend to be really, really long or extended in time. And really with a 4D representation of past or future events, there is really no ground for disagreements, but rather a reason to find the best solution for the problem. And we really saw that happening as well throughout the project. And so that was very valuable. So for example, just 2 examples on the right-hand side, there is how much floor slab there was available in regards to how much drainage work that needed to be done, and on the left-hand side there was a particular ramp to the basement levels that was very intricate. So we could very easily kind of see what has been constructed around it already and what needed to be done next. So I will come now to the Synchro benefits and values. And as a real believer in 4D, I find it very easy, certainly, to understand the benefits and values. However, I thought for this webinar, I asked a few colleagues of mine as well from BAM to tell me their view of Synchro and how it helped them and what they thought of it. So here are really the statements: that it facilitates the communication of the program very easily, that it's time saving to explain the construction methodology, that you gain faster agreements on what will be done and what will not be done because of the illustrations, the flexibility of it, that you can cross-check and validate the plan, increasing program accuracies, allows to explain to non-construction stakeholders, which was a really big plus, and it was one of the biggest benefits really for everyone, that it was just very easy to understand what was planned from the planners. Peer reviews are made simple, and because the Gantt charts are often difficult to understand, it's very useful to illustrate the critical path to the team. It supports transparency. Like usually in Gantt charts, many items can be invisible or hidden and invisible, but through the 4D, you can't really hide it. Everything is visible. So that's a huge benefit as well from the investor's point of view. And it facilitates an easy communication of complex interdependencies between companies and scopes. Constraints were made visible for others. It enables easier scenario planning, and it's really a low-cost rehearsing, rehearsal really. And I just wanted to as well get a little bit into the kind of a little bit of advice how to best use 4D and Synchro and what really needs to happen and how you get the best benefits from it really when you implement it. And for me, this is really that if you have a detailed construction schedule, the more benefits can be achieved through 4D. It works as well with a high-level schedule, but really, a detailed, intricate schedule is probably the best way to go, and you will achieve really great value from it. The time effort required to create both program and 4D model are longer than usually would be. However, it really balances each other out through the value that you get. So, so really the time needs to be incorporated in the pre-construction phase, in the construction phase, that it requires some time. However, just like a rehearsal, if you look at it several times and you plan it out, you will benefit from it, because afterwards, during the construction, the time is going to be faster, therefore. The model preparation by the BIM team and designers are really important, because just like I showed in one of the topics before, the concrete pours were really complex and non-standard, and in this project we had to divide them ourselves. However, there is a possibility in design and build projects that the whole team is already talking throughout the planning about what core regions are going to be, and possibly the designers can already model their model in such way that facilitates at least the 4D creation. And for me as well, 4D workshops are the key. And this is not only showing the animation in itself, but really kind of going, day by day, week by week, and really stopping and looking at it, analyzing from different perspectives and views, and to have really all project stakeholders, involved in the process, because it's just not possible that one person sees all the faults and the problems and the issues that could be in the future. The more people look at it, the more benefit you will get from it, the more issues might arise, and that's probably for me the most important part, that really as many people as possible should look at it and really discuss it through step by step. So that was it for me. Thank you so much. Thank you very much. And if you have any questions, I'm happy to answer them.
Yeah, please, if you have any questions, either punch them in the chat now, or as Monika's put on the screen there, either reach out to her on LinkedIn or email, or the usual kind of suspects. I guess one thing I'd like maybe to ask, you showed early on kind of how the scope grew very much, or very quickly throughout this project. Can you kind of talk around how those conversations developed? Was that a result of, say, the value was seen in 4D early on, and then we decided to try other things? So.
Yeah, I think it was definitely a benefit that the contractor engaged us and the 4D very early on, right? So even before, long time before, there was talks about concrete works, because usually 4D is being done with the structural frame and possibly the facade, but very rarely anyone thinks about the excavation, right? It just happens, just kind of happens. But we were engaged from the very start after the tender, after I succeeded with the tender, we were engaged from the very start. So the planners, because it was so difficult, the excavation, thought it was a good idea to link the excavation schedule as well back to 4D. And we very quickly realized that there are problems. And therefore, it kind of speeded the process up to really analyzing back and forth and illustrating it. And from my talks with the planners, they were just very happy to do that, because it helped them to communicate with the client as well what is going to happen. It was just very difficult to do that otherwise. And all the other stuff. So once people on the project see a benefit, a real benefit, where it makes their life easier, right? It becomes kind of like a domino effect, right? Other people come, and because it's such a visual thing, and this, I think in our life, like everything that we see first, we kind of gets better. So everyone that saw the schedule, was interested in what it is, and then quickly realized, oh, can you actually show me this, and is it possible to show this? And that's how it kind of rolled on to become more and more and more.
Well, the value was there, as they say. So look, there haven't been any questions rolling now. As we said, feel free to reach out to either of us.
Yeah, I think I see one person asking, hi, thanks for sharing. Do you have a dedicated 4D team for this project? Yes, there was a dedicated 4D team for this project. However, it was more to do that I was the 4D manager, and then the models were prepared as well by the BIM team, right? So it was a bit kind of, like parts were done by myself, and parts of the model, that was needed for the 4D was done by the BIM team, right? However, I would also definitely say that the bigger the project, you do need a dedicated 4D team, and not only one person, but more people, because it is a huge task. But as I say, it has as well a lot of benefits when it's done right. So definitely a dedicated 4D team is necessary.
Yeah, sorry about that. I can't see the questions on my side. So.
It was just this one on my side anyway.
Okay. So I think that'll be it for today. Thank you everyone for tuning in.
Okay.
Yeah, feel free to get in contact with us online, and yeah, have a good day.
Yeah, thanks a lot. Bye.
And of course, thanks Monika. Brilliant presentation.
Thanks.
Cheers.
No worries. Bye bye.